Hello, my name is Borislav and I am from the class SQ. I'm in group 1 together with Batch, Victor and Jafar, and I'm going to be the one to show our project today. So first of all, I'm going to start with the requirements that we had. This year are the pilot requirements, this year are the ground control requirements. I'm going to show that our application is written in Java and that our application uses Saxion communication library to connect the frog, the ground control, and the pilot. So this here is our code. Everything's written in Java. All the classes are in Java. Here, database, everything. So this here is our method that we use to send the message to ground control. It uses Saxion server, and we use it also to send messages to the frog. This here is our ground control. The ground control can only send messages to the pilot, and this is the method that we have. So now I'm going to show that our application uses a database for the pilot and for the ground control. This here is the database for the ground control. This here is the database for the frog, for the pilot. So now this here is SQLite Studio. Here you can see our tables. This is the pilot database, this is the ground control database. More about our database is going to be, more information is going to be in our functional design. So now I'm going to show that our application for the pilot and for the ground control uses a graphical user interface, which is in Java Swing. This here is our pilot dashboard. It uses JFrame. And here is our ground control dashboard that also uses JFrame. Now I'm going to start the program so you can see our dashboards. This is the pilot dashboard, and also when you run the pilot, the frog also runs. Now when I run the ground control, this is the dashboard of the ground control. The first thing that I'm going to show is the manual mode. I'm also going to show that the position of the frog is shown on the 2D map of the pilot. This here is the pilot dashboard. If you go to menu drive here and you press on, that's when the menu drive is activated. So now I'm going to press W, it goes forward. I'm going to press W and A, which would go left. If I press backwards, it would go back. Well, sorry, if I press S, it would go back. If I press W and D, it will go to the right. Now my idea is to show that the frog can prevent collisions in manual mode. I'm going to show only in manual mode at the moment. I'll show the automatic mode later on. Oh yeah, I forgot to show you. This here is the dashboard, as you could have probably seen. The yellow rectangles that appears are the driven route, and the triangle here is the frog's direction. So I'm going to show this first. If you go backwards, yeah, the direction changes. So each time that I go backwards, it changes, and also the radar points are also displayed. The yellow thing that you cannot see at the moment is the driven route. So now I'm going to try to show you that the manual mode can prevent collisions. So now forward, and I try to turn the right. Yeah, it appears a message dodge, which because I'm trying to go to the right, and it can see that there's an obstacle and it doesn't let me. It doesn't matter how many times I press, it doesn't let me do it. Now I'm going to show you that the driver can view the received radar points in a 2D graph. If you go to the pilot dashboard, now because I'm in manual mode, I cannot do anything. If I press it again, now it's off, then I can do all of these things here. If I press on the collision map button, yeah, as you can see, the pilot is next to this, and this is a visual representation of all of the points that have been detected since the last radar scan. And this here is the frog. I'm going to show you that the 2D map on the ground control also works, that you can see and follow the position and direction of the frog, which would also mean that the frog can send the coordinates. So now, as you can see, here you can see that the driven route is the same. So if I try to move, you'll see that it will move in both places. Yeah, as you can see, it moves here and it moves here. Another requirement is that the operator can request a map, a list of detected obstacles, and here the frog can send a map of the world. Basically, it can send the obstacles. Now I'm going to show you this. We have made it that this button, request detected obstacles from for the frog, when you press it, it would send these points here. So now this is empty. If I press the button, all of a sudden it's not. So now I'm going to show you our automatic mode, which meets this requirement here, and that the operator can request the frog to drive to a specific location, and it's going to meet this requirement here. And also I'm going to show you that it can prevent collisions. So I restarted the program, and now I'm going to say to the frog to drive me somewhere here, for example, and now it will start driving, and now I'll just fast forward. So now it said dodge, which means that it detected an obstacle here. Oops, sorry. And now it's going to try to avoid that obstacle. Let's see. Okay, so after a long time, but a very precise and good driving, may I add, the frog has reached his destination. And it can be seen here on the ground control dashboard. This green dot means that this was where I said the frog to go, and that's what happened. It evaded an obstacle, so it met the requirements here. Okay, now that I showed you the automatic mode, now I'm going to show you these requirements here. First of all, I'm going to start off with the mission can be exported and ported from a CSV file, and also a mission can be saved in the database. So I'm gonna come here. I have restarted the program because the last time that I tried to show all of these things, I took too much time, so now I'm trying to do it faster. So we have a button add mission. Here you can add a mission. I'm just gonna do test, write a description, and I'm going to add some commands. Okay, so now I have added 2 commands, and I'm going to press send. And as you can see, the frog starts doing the drives from the mission. Now, the mission has been saved successfully. That means that each time that basically a mission is created, it's automatically saved in the database. And here is the database, and if I refresh it, here it is. So the next thing that I'm going to show you is that you can export the mission to a CSV file. I'm just going to open it like this. So if you press export mission, it says mission exported successfully, and here in the console you can see that the CSV file was saved. The CSV file basically looks like this. It's the same as in the database. So I'm going to use the mission to import it. First you need to find it. Okay, now I have found it. Here's the mission. I'm just going to press open, and as you can see, it automatically does the drive commands in the mission. Now I'm going to show you that the same for the collision points. So first of all, I'm going to request the detected obstacles. Then I'm going to say to press to save, and if I come here and I refresh, all of the radar points would be here, and there's 3 pages at more than 2,000 points. So if I come here, this is now I'm going to import. No, I'm going to export it. So if you press export collision point map, it would make a new CSV file, which would look like this. And if I try to import a file, I have created a file radar point test, which basically would make that a line would appear here. So if I press open, a line appears here and here. These were all of the requirements. Thank you for your attention, and goodbye.